You can start. Tejas, you'll be presenting now.
Yeah. So, am I audible and is the screen visible?
Yes.
Okay.
Yeah.
Okay. So, today let's understand what is exploratory data analysis, EDA. So, basically, EDA is the process of visually and statistically summarizing a data set to understand its main characteristics. So, why do we perform EDA? This is mainly to get useful insights from the data, identify patterns and relationships between variables. So, we'll understand with an example further. So, why is EDA important? It provides initial insights into the data, helps to understand your data better, detects any errors or missing data, helps with feature selection for modeling, that is predictive modeling, and also EDA can reveal hidden trends that lead to better decision making. So, what are the steps in EDA? We have mainly four steps: data collection, data cleaning, data transformation, and data visualization. So, coming to data collection. Data collection is collecting relevant data for analyzing purposes, and it can be of any format like Excel, CSV, etc. And it is important to collect relevant data so that it is related to business or research to be analyzed. And during the collection, it is important to ensure that it is accurate, complete, and free from any inconsistencies. Of course, in the next step, we'll be doing all of this. And but initially, we hope so that the data is completely free from any errors, so that it prevents any misleading conclusions. Next, we have data cleaning. So, mainly it involves identifying and addressing null values in the data set. So, common approaches include removing the incomplete records or adding the missing values using techniques like mean, median, or mode. So, basically, we substitute these three values as they are simple and not biased in any way. So, and also it is an efficient way of adding the data if there are any missing or null values, and correcting data inconsistencies and outliers ensures that data values are consistent and they fall within expected ranges. This involves standardizing formats, fixing typo errors, and removing or transforming outliers to prevent them from skewing analysis results. Basically, we ensure that the data is within a given range, and we remove the outliers so that it can cause any errors for uh, future prediction. So it is important to clean the data. Coming to the next step, we have data transformation. So in this we have rescaling data, like adjusting numbers in the data set to bring them to a similar range so that no single number is too big or too small compared to others. And changing categories to numbers, that is, for example, converting text categories like yes or no into numbers so that They can be analyzed or used in models, as many of the machine learning models understand easily when provided with numerical values. So it is easy to provide numerical values than any textual values. Yeah. And the last step is data visualization. So it is the graphical representation of information and data. We use visual elements like charts, graphs, and maps to provide an accessible way to see and understand the trends, outliers, and patterns in data. It is a crucial step in the data science process, helping to identify insights and communicate the findings effectively. Yeah, so these were the four main steps involved. And coming here, we have tools for EDA. The different Python libraries we can use for EDA are pandas, matplotlib, seaborn, and plotly. R libraries we have ggplot2, dplayer. Other tools are Microsoft Power BI, Tableau, Excel. So these were some popular resources for EDA. And coming to the visualizations, we have various types of charts, maps. Example: pie chart, bar chart, column, line, area, donut, scatter, stacked bar, gauges, etc. The usage of them is dependent on the data. So for comparison purposes, we can use bar chart, column chart. To analyze the trends, we can use the line chart, area chart, and for any location related data, we can use the maps, etc. So this is a simple example of EDA. Anyway, I'll show another example of the Titanic dataset also. Now, this is a simple example. Uh, we have a data set of India population in Excel format as below. Consider that we have the state, population, percentage, male, female, and difference between male and female. So these are some of the columns we have in the data set. So using Power BI, this is just a sample to show you that what can be done using EDA. You can plot a donut chart to show the population in each district, and also represent various dashboards, and also some pie charts to show useful insights like what is the male count, what is the female count, and also sum of density, etc. So yeah, it provides useful insights into the data so that you can perform any good decisions based on this. Yeah, and coming to the conclusion, so mainly EDA helps in understanding the data and decision making. It is crucial for preparing data for modeling and identifying the key features. So the next steps after EDA are we can move into deeper data analysis or predictive modeling using the various machine learning algorithms. Yeah, this was pretty much of it. So anyone has any doubt regarding this?
Nice presentation, Tejas.
Thank you.
I don't have any much questions. Maybe once you show in the Titanic dataset and do the EDI, I will
Yeah,
have questions.
sure.
But the presentation was very nice.
Thank you. Yeah. So, excuse me.
Poonam is here. Hi Poonam. Hello. Hi. We just finished the presentation and was starting to do the EDA for Titanic Dataset. Maybe Tejas, you can give a brief intro to her.
Yeah. Hi, Punam. Yeah. So we were discussing about introduction to EDA. Uh, so what is EDA? EDA is the process of visually and statistically summarizing our data set to understand its main characteristics. So it is mainly done to uncover the patterns, spot anomalies, and form hypotheses, and mainly to understand your data better and make informed decisions. So the importance of VDA, it provides initial insights into the data, detects errors or missing data, and it helps with feature selection for modeling. And an example include EDA can reveal the hidden trends that can lead to better decision making. Yeah. So these are the mainly four steps which we use in EDA: data collection, data cleaning, transformation, and visualization. And so coming to data collection,
Tejas, you don't need to explain everything from the beginning. You can just give
okay,
a brief.
okay. So collecting the data, required data for analysis, and next step is data cleaning. So it includes handling any missing data or correcting the inconsistencies. Next, data transformation. We we have two steps like rescaling the data and changing the categories. Next step, we have data visualization. So it is mainly the graphical representation of information and data. And coming to the tools, we have these tools: Python, we have Pandas, Matplotlib, Seaborn, etc. And other tools are Power BI, Tableau, Excel. So these are some visualization in EDA. And example of EDA, I'll explain now using the Titanic dataset. So this was it, an introduction of EDA. Yeah. So coming to the Titanic dataset, we have around 12 columns here. So the first column represents the passenger. Next, whether he has survived or not. If the value is 0, he has not survived. If the value is 1, he has survived. We have passenger class and the name of the passenger, gender, age. Then this column is for siblings and spouse. This is for parents and children. So if the value is 1 over here, there is one spouse or sibling plus the passenger traveling. If the value is 0, only the passenger is traveling alone. And same here in the parents and children column. And we have the ticket number, fare, cabin, and embarked. Embarked meaning where the passenger boarded. So here, S stands for Southampton, and Yes, we have other two places. The pronunciation is a bit difficult here. So C stands for Cherbourg, and Q is for Queenstown. Yeah. So first step, we import the libraries necessary for the EDA, and I run it. So next step is I load the data set, and so next I inspect the data. So for example, first few rows of the data set, we have these values over here, the same which I explained, and shape of the data set, that is the number of columns and rows. We have 891 rows and 12 columns. And next, data types. So you can see we have int values, object, float, etc. Next, we have something called as summary statistics, like what are the parameters present in each column. For example, in passenger ID, we have a count of 891, which are same for every other column. And the mean for this column is 446. And the survived percentage mean, we have 0.38. Then standard deviation, we have 257. Here 0.4, 0.83, and the corresponding values. Yeah. So next, I check for any missing values present in any columns. So after that, I find that we have some missing values over here in the age column and cabin column, and also in the MBAC column, which are of the data type int. Next, I visualize the missing values using a heat map. So I can see here that age column has some missing values in this pattern. The yellow represents the value which is missing over here. And you can see in cabin, we have most of them are null values or missing values. In MBAC column, we have two missing values. Yeah, this I can confirm that there are majority of missing values in the cabin column. And next step, I have univariate analysis, the distribution of age. So use a histoplot over here for understanding the age group which are traveling, which have the highest frequency for traveling in the Titanic now, right now. So we can see that age groups having ranges between 22 to 24 are maximum, with a frequency of more than 70 or more. So majority of them are within young age. We can confirm like that, and the trend is decreasing as we go. So there are less number of age people. We can conclude that. So next we have something called as count plot. So basically to show how many male or female have survived, survival count by gender. So the blue represents they have not survived. The yellow represents they have survived. So in male, we can see that majority of them have not survived, and whereas in female, majority of them have survived. So comparing to male, many of the females have survived. This is what we can confirm from here. So next we have survival rate by embarkation point. That is the point where the passengers boarded. So yes represents here Southampton. We can see that many of the passengers who boarded from here have not survived, and the persons who boarded from Cherbourg, here also they have the survival rate is a bit higher as compared to the people who boarded from Southampton. And in Queenstown, we have number of survivors less as compared to uh, Cherbourg. Yeah, so these were pretty much of the data analysis. And also last step, we have a correlation analysis. So I have added a heat map over here to show what column is dependent on other column. So the cooler colors like blue indicate that they have less dependency, whereas the warmer colors like red, they have maximum dependency. So for example, if I consider the survived column, so it is not if the value is equal to if it is more than zero, we can say it has a little dependency. If it is one, it has maximum dependency. If it is less than zero, there is no dependency.
If it's less than zero, is it not negatively correlated?
Yeah, it's negatively correlated.
So in that case, that is a dependency, right?
But I don't think like these values can affect the column.
So I'm not sure, but I'll have to look at the formula. But
Okay,
negatively correlated means if one increases, the other decreases, right?
okay.
So in that case, the weights can be in such a way, and that can be actually used, right?
Yeah, correct.
No, in terms,
So
or yeah.
if one value increases, the other decreases.
Mm-hmm.
Or
Yeah, yeah. Actually, we want a very little correlated, right? So if it's either of them is, yeah, if it's zero, we can use,
yeah,
and if it's high, if either ways it goes, then the correlation is there, and we
correct.
might not be able to use that for predictive modeling.
Yeah, that is true.
Actually, in here itself, I think there's an example, fare and passenger class, I think.
Mm-hmm.
Um, it is negatively correlated, right?
Yeah.
Mm-hmm.
Okay.
Actually, I have a doubt.
Yeah.
So when do we remove like features? We have to remove some which are not correlated, right? Where do you uh, have that limit?
You mean to say the outliers, is it?
A correlation between features, right?
Yeah.
Here it's multi-collinearity, I think. I mean the correlation between the data and the thing that we are trying to predict. So if there is like zero correlation, we remove it, right? But
Yes,
here,
yes.
Dhananjay said there are negative correlations too.
Yeah, highly correlated means that information is already there in some other variable, right? So in that case, we don't need that column. If it's like 90% correlated, then in that case, that information is already there in other variable. So we can create a model without that feature also.
If it's the correlation between the feature and the thing we are trying to predict, right?
Yeah, that
is
case is
useful.
different. Yeah.
So we should remove a feature if it is too correlated to another.
No, no. If it's target variable and the feature, in that case, there should be correlation, right? Then only that will give some information to predict.
Correlation between features, if two features are like highly correlated, should we remove one?
We should remove.
Yeah. Yeah, so this was the pretty much of it.
Anyone else
Yeah,
who
nice
has
presentation. Of course.
done Titanic dataset? Nice, nice.
Thank you.
Anyone has doubt in those? Shalini was asking something, I guess.
No, I was telling the presentation was nice. I could just.
Thank you.
I actually did Titanic actually.
Yeah, you can.
I also did one with respect to cars data set. I didn't take the other. Like I found an easy one, so I just tried it out.
Let's finish Titanic dataset first, then
Yeah.
we can go to others.
So the question which for us, right, that is related to feature engineering. Is it?
Yeah.
Okay. That is different from EDA, right?
It's you can say that's part of ADA, but
Okay. Okay.
either way it's fine, I guess. Naming.
Yeah.
I think I'm a bit confused now. So when do we remove it? There's like zero correlation or high correlation. Or do we remove it both all the time?
We don't. One second, let's ask GPT then. Yeah, we should remove if it's highly correlated. Between the features, if it's highly correlated, then we should certainly remove.
So if the correlation between the feature and the thing we're trying to predict is high, we keep it.
Yes.
So we have to manage those two. Correlation between features and between the thing we're trying to predict.
Yeah. So like it explains like issues regarding that. It can lead to like unstable estimates of model coefficients, and also since two the weights would be similar in two features, right? That can lead to overfitting, and it's also if there are so many number of features, then that will cause more. We need more computation. So in that case, it's better to remove this features.
So should I present? I actually did ED on Titanic
Yeah.
Dataset. So um, first we input NumPy and Pandas. It is somewhat similar to what they just did, but after that we read the CSV that contains the Titanic dataset that's here. Then we just look at the data and see what are all the contents are. So here we have passenger ID, the people who have survived. Uh, if it's 0, it means they didn't survive, and if it's 1, it means they did survive. P class, I think it means like the tier of luxury. 3 is the lowest and 1 is the highest. We have sex, age. As you can see, some of the age missing. When you when you have siblings or spouse, when you have parents or children, so this counts if you have a sibling or spouse. This tells you if the passenger had parent or a child with them. This is the ticket, this is the fare, and this is the cabin number that they had. As you can see, this is mostly null. This is the embarked city. We have SC, the two cities. So the first business is what columns will contribute in my analysis and what columns are not useful. So let's look at the shape of the data. So here the shape of the data is 12 columns and 891 rows of data. So we can compare how many data are missing based on this number, 891. Then we will look at the info. This function allows us to see various things about each column. Passenger ID has 0 null values and its D type is int64. And you can see the most null value is in cabin where it's like only 204. That's like more than 60% is null. Age also has some null values but not as much. There are some mistakes like this is flawed, this is supposed to be int since age is usually written as a whole number. Then we use describe to see various things about each things about the table. I use transpose here to just transpose you can just see it. Transpose just makes it a bit more readable. So the passenger, this shows the count, the mean, the standard deviation, the minimum value that's in there, the 25 percentile, the 50 percentile, the 75%, and the maximum value that was in each. So as you can see, the minimum fair amount was 0. I think that's an error. The maximum was 512. So that's something. The minimum age was 14. The maximum age was 80 and so on. Uh, this checks for missing values in each one. As you can see, age has 177 missing values, but cabin has a lot. which is 687. Embarked is the least amount of missing values, it's like only 2. So we handle each missing values. So since age has good enough missing values, right? Not that much, we just find the mean and fill all the missing values. So that's what this code of line, this code does. But cabin has like very less amount of uh, data. So you can do two things here. One is to just remove the table completely, or you can just keep it and fill the NaN values with like no cabin. So it's up to you. Then for embark, since there's only 2 missing values, we just remove that subset where it's NaN, and we just do the thing again. So as you can see now, we have 0 NaN values, which is always good. So then we handle incorrect data types. So mostly this data set has good data types, but we make it a bit better. So as you can see, the D types here, right? The passenger ID, the survived class, the P class, it's all in 64, which is actually right. But name is supposed to be a categorical data type. So as sex and embarked, age, parent and child, sibling and spouse can all be int 34. The reason we turning in 64 into 32 is because it takes up less space, and we know that age cannot be that big. So does parent, child, and sibling spouse. You can have 1,000 parent child. So we know it's less. So we just change the type so we can save space. And for good measure, we just make a copy of the data. Now we check it again to see all the data types. As you can see, we've changed the data types of age, sibling, spouse, parent, child to 32, and we've changed all of the others into categories from objects except for name. Then we make some simple plots. Before plot, we will just see like basic information about each column. So we'll see how many people survived and how many didn't. So almost 61% of people actually didn't survive, and only 38% did. As you can see, about only 300 and something people survived, and more than 500 people actually died. Now we see how the distribution of people were among classes. So the first class actually had the lowest class actually had the highest amount of people, about 55%. The second class, the highest, the most luxurious class actually had the least amount of people, and no, the most luxurious also had like about 24%. The middle second class had the least amount of people. If you look at the distribution of sex, there were more males than females actually. And if you plot age in a histogram, you will see that the most amount of people were in their mid 20s to 30s. So working adults were the most people who were in the Titanic. This is just a distribution plot to see as you can see, the age has a normal distribution somewhat. And if you look at the box plot of age, you can see that there are a lot of outliers from ages 60 to 80. Those all can be considered outliers. Now we see how many people traveled with siblings or spouse. So almost 600 people traveled alone. About 200 people traveled with at least one sibling or spouse. And as you go down, only about 5 people traveled with 5 siblings slash spouse. And the same can be seen from the parent child with a symbol bar plot. You can see that as most people traveled alone, and as you see that one per about more than 100 traveled with at least one parent or child, and a bit less traveled with at least two. And you, as you go down, there's significantly less amount of people who travel with parents or children. You can see 5 is uh, surprisingly more people traveled with 5 children or parent than 3. That is something to note. And if you look at the fare, most people paid around between 100 and for 50 something. But as you can see, there are a lot of outliers from like 100 to 500. This is a major outlier here. Someone actually paid more than $500 to get in. And if you look at the uh, histogram plot, the fire is actually right skewed. It means that more people actually paid less to get in than the fare. Now we see the impact data set. So 72% of the people embarked from S, 18% embarked from C, and 8% embarked from Q. So what are the conclusions we can make from this? More people died, about 62%, than survived, which is about 38%. The P class 3 was more populated than P class 1.2, which means more people died because they were lower down the deck. There could be correlation between the percent of people died and how many people died in P class. More males were on board in compared to females. The range of ages between 0 to 8, there are a few outliers in that data as we've seen. And the fair column has a fair few outliers too. And as you've seen, the data is actually right skewed. And most uh, passengers on board got embarked from the S of Southampton. That's about it. Thank you.
Nice. Wonderful.
Yeah. Just one doubt I had, like with age, right? Can that be? Can you show that age outlier box plot, which is?
You mean this? No, this is fair.
The above one, I think, age outlier.
Yeah, this.
No,
Age
the
outlier.
box plot. Like my doubt was, can we consider outliers in age?
Outliers, it means this is the graph
Like
you're
just,
talking about.
yeah. We're not removing as such. We have the data. It's just to show that quite a few of them are above 55, 60, right?
Mm.
But,
What was your question again?
No, just like you've
No,
not
I
done
think.
anything with the outliers, right? You've just showed it. That's all.
Mm,
Yeah,
Okay. Oh, okay.
I
Okay.
think feature engineering is where you like do all of the corrections with outliers. This is just like seeing
Okay.
everything. This is just analysis.
Okay. Okay.
That's what I believe.
yeah,
I
but
think that is
yeah,
the
here na the box part of it has the major portion of the data.
yeah.
Mm-hmm. Yeah, got it.
Yeah. Anyone else with the Titanic dataset? No. Uh, Boston Housing, who has done? No.
I chose another data set, so I had done for that.
Okay. Cool. Yeah, you can present.
Okay.
I also did a very little thing on Boston Housing, but you can present first. I did very little.
Yeah, mine is also like very simple
Yeah,
actually.
you can start.
I just okay, I'll present it. Are you guys able to see?
Yes.
Yeah, just use the simple cash data set. Um, so I uploaded it took it from Kaggle. So basically, these are the columns: the make, model, year, engine fuel type, HP cylinders. Quite a lot of columns are there. Um, Actually, I kind of wait. Let me scroll further. So this is just displaying the data and the types. Um, Around 11,000 number of rows are there. The thing is, I did some modifications to the data, so I was just trying out a few things.
Mm-hmm.
Maybe that is not a part of VDA,
No,
but
no, that's fine. Duplicates you can remove, I guess. Cleaning.
duplicates I removed, and then null and missing values also. Since these two are less, I removed it, and
So as we
then
discussed, na, data cleaning,
yeah,
data
yeah,
transformation, all those are part of EDA.
yeah. So this market category, I not considered it. So these two columns I removed. Like I was trying to find insights from the other columns. So if you see, these are the main columns which I'm considering. Mainly engine HP, cylinders, make, um, and then the price. MSRP, this is the price. I've renamed some of the columns for better understanding. This is after renaming. This is the columns I'm considering. And yeah, just the same few steps. We dropped all the missing or null values. I didn't substitute it with mean or median since it was less only. And this is just to find out the outliers. This is with price. If you can see, mostly the price is around. This is in lakhs. Um, there are quite a few which are very high priced,
Mm-hmm.
and yeah, price. Okay. This is horsepower. Most of them come in the range of within 500. Some of them are above that. And cylinders also, most of them are around 3 to 8. There are some with 16 and 12. I think these seem like outliers. So that's what this example they had shown with removing these outliers also. But I'm not. So I just tried doing it using interquartile range score. So basically, I find out the upper bound and lower bound, and then I've tried to remove them. Like I'm using only numeric columns. I'm selecting and then doing this modification.
Can you pause for a second? So
Yeah.
the lower bound will be Q1. What is Q1? Okay.
Q1 is.
Q1 is the numeric TF quantile of 0.25.
So I tried with this. This was not working because it was considering string columns also. Then I found out we have to use only like numeric data frame. So out of that, I tried to select only the numeric columns, and then I did this.
Okay.
So that's what I find out the upper bound and lower bound, and remove those which are lower than the lower bound and higher than the upper bound. So around 1600 were there. So those I have removed.
So,
Like this is just for analysis for me to try out, get familiar with these pandas libraries, plot, matplotlib, and those libraries. I was trying out a few things. And yeah, this is a simple histogram bar chart where this is the number of cars and for each brand. So here, maximum number of them are from Chevrolet. And the next is Ford. I think least is quite a few brands are there. Not heard. And yeah. So the next one, I've tried to again upload a correlation map between these features. So mostly from what we can see, price and price is mostly dependent on the number of cylinders and horsepower. And negative correlation, I've actually not checked. I need to see that.
so is the price the target?
Once again.
Are we trying to predict the price or?
No, just yeah. We can consider price as a target. Now, for now, I just try to analyze with related features. I've not considered target. And then I just tried using a scatter plot to compare horsepower versus price and cylinders versus price. So this, from these charts, these are simple charts only. What I mainly wanted to find out was to see which brands have higher horsepower with lower cost, or which brands have more mileage. So there were two columns with mileage on highway, which is MPGH and MPGC. This is city mileage in city and mileage in highway. So these could also be found out.
Are they correlated? Like
Um, not sure actually.
MPG, yeah, it's very much correlated. I see MPGC and
And
MPGH is very much correlated.
yeah, these two are correlated, I could say. Uh, but will that help? Like,
No,
as
no,
in, it should be also dependent on either horsepower or cylinders, maybe, I was thinking. I'm not sure.
no, no. They are correlated with each other. I was just
Okay, yeah, yeah. Yeah, so that was pretty much it. Anyone has any questions?
nice. It's good. So I think it's already 8:30. I can maybe skip. I have not
Okay,
done
that's
much
all.
with it. I have also plotted like similar stuff only. So maybe I can just give a conclusion. So today, like we had like a very nice discussion introduction to EDA. So I think from all of us did few similar things. Like first look at the data, then
Mhm.
Yeah.
like understand what is there in the data, number of columns, how many number of columns, are there any missing values, all those things.
Mm.
Yeah.
And then correlation is what everyone does, I guess, as the next step. Like everyone is doing correlation. All of us did correlation. So we can try to understand like when to remove and when to keep features.
Mhm. Yeah.
Uh, just to add on about the correlation part, so when we say it is highly correlated, it means like we usually set a threshold, right? Like either about
Mm-hmm.
0.85 or zero point 0.9, either negatively or positively. If it crosses these values, then I think we can say it's highly correlated. I think anything between like maybe 65 or 70 to 80, 85 would be like moderate level correlation. But I think when it comes to really removing or keeping the column, it's very specific to the data set. So these thresholds
Mm-hmm.
we cannot generalize it.
Mm-hmm.
Or, but just a rough number would be like around 85, 90 for very high correlation.
Mm-hmm. Yeah. And one more thing we can explore further is like imputation, like when to use mean, when to use mode, and like when do we use
Yeah,
the.
more in-depth uses of.
And also oversampling, undersampling. I mean, there are libraries for it, but when to do it is something we can explore.
Oversampling and undersampling from the data set or while we
Yeah,
get the sampling.
I think like if there is imbalance in class distribution, yeah, I think that comes in classification problem. So if there some class is represented less or some class is represented more, say out of 100 data, like 100 rows you have,
Mm-hmm.
and if you classify in the beginning what do these in a classification in a 5 class classification problem,
Mm-hmm.
and you find that maybe 60% of the data belongs to only one class, then I think you have to do like undersampling, or, and if it's something is not well represented, maybe if it's one class is only 1%, we may have to do
Mm-hmm.
over. I mean, this is just a rough idea, but I think I mean we have to explore to answer this properly, when to use undersampling, oversampling.
Yeah, definitely. So for
I think to that extent, I also wanted to ask if, let's say we have three, what do you call, three sections on the same feature, 1, 0, and 2, and we have a lots of we have a lot of ones and zeros, but not much twos. So is that because of our sampling, or is that how it is distributed?
okay, that
That could be, yeah, go on.
it can be either way, I guess. If we are for this Titanic, right, there is no sampling involved here because everyone who went in Titanic, we have the data. But suppose here for cars, we might not be able to get data of all the cars. So in that case, we will have to see whether how well the sampling procedure was. So we have to be very systematic. We have to do random sampling. Then we have to look whether we have like stratified sampling, like we have separated it into different groups, and from each of those groups we have done random sampling rather than just limiting to one type of group by sampling. All those can lead to these issues of having data from only one particular class. So there we have to be very careful, and for how we deal with this is using like I said, oversampling or undersampling, using smart library, I guess, adding classes like data of the same class in the data set.
So we like eliminate certain features in EDA based on like it's too skewed in like uh, one section, as in like if it has like 1,000 zeros and only like 100 ones and maybe like 10 twos. So do we remove that?
We can look at something called information gain, I guess. There is something called information gain that we can look at, and if there is any information that is gained from that column, then we can use that. Like that also based on threshold. Like suppose every column is having same value, then that weight does not matter in the prediction. So there is nothing that model learns from that column. In that case, we can remove. That will come with the correlation, I guess. If you plot the correlation between the target variable and the feature, then actually since every value is the same, there is no change in the target variable with there is no change in the feature with the change in the target. So they are not much correlated. So we have to be highly correlated. Like the changes in the feature has to reflect in the changes in the target.
But wouldn't it couldn't it still be like correlated even if some amount of the data is like bigger than the other? Like if there are 1,000 ones, it could still be correlated with the output, right?
So in that case, the target is also not varying, right? If it's not so there is change in the target, but there is no change in the uh, feature. Say then they are not much. Uh, we have to see whether there is any information gained from that.
But by doing this oversampling or undersampling, how it affects correlation is I mean, it may or may not affect correlation.
That is separate thing. Like that's to have like a better model.
Yeah, oversampling, undersampling is to Yeah, to predict better, right? The model performance increases. Yeah.
Uh-huh. That is for the like a classification problem. The target is like a skewed, like few features, but in
Mm-hmm.
terms of features, we can decide whether we should keep or remove. We
Yeah.
are like in a very bad situation that we have to deal with this data set, then we do oversampling or undersampling.
Yeah.
We are not able to get
Do
that
you
time.
have any tips on how to deal with this?
Smart is there, like for features, like better sampling method would be one. Like when we acquire the data itself, we have to look at the features that it is not skewed. And smart, like oversampling, undersampling is done if it's the target. Yeah. We can maybe next class look at some few basics of statistics,
Yeah.
like sampling, all those things.
Yeah.
Let me see. I have done a course. Maybe I can present from that, and anyone else is also interested, they can present.
I think you can present. You've done the course already, so I think you know much in there.
Cool then. Okay. Then let's pause. We had decided on gradient descent, but let's maybe it's more important
Yeah,
to
I think
understand.
statistics is better before that.
Great. Cool then. Anything else you guys want to discuss? Any? I think it's already 8:40.
Yeah,
Mm,
sure.
anything else? Any? Poonam, you have any questions?
No, not now. If I have any question, I'll ask you. Well,
Sure.
later
And
on, definitely later on.
sure.
Thanks.
Nice. I think we are now comfortable in using pandas and doing all those ADA stuff. But
Yeah.
more understanding is required, I guess, in why we are doing all those things.
Correct. Yeah.
The decision making as to why.
Hmm. Yeah. So, yeah, let's try to have a session on that next time.
Okay.
Yeah, everyone just read about it so that you will ask more questions, and whenever someone is presenting wrong, you can correct them.
Yeah.
Yeah.
Mm-hmm.
Right.
This Josh Stummer PDF was good. I started with the first chapter. This anyways.
So, Dhananjay,
What should we read about?
Statistics, like sampling. I'll try to prepare like a syllabus next week what we will be presenting, so everyone read and come. I'll try to present, ask maximum questions,
Yeah.
and if I am not able to answer, others should answer. Poonam, we are like from mathematics, so no one of us knew, you should answer.
definitely. Pure mathematics question, I'll definitely answer.
Statistics, yeah, statistics questions, yeah. Cool.
You give me geometry topology questions, I'll definitely answer. If you
Yeah,
are
yeah.
asking about correlation matrix and then inference and all things, so
Mhm.
I'll have to think.
Cool.
Have you recorded this lecture?
Yes, yes.
Okay.
Okay, I'm stopping the recording now.